Welcome to Grade 8 Mathematics, Unit 6, Cyber Class. This is the unit on an introduction to probability. This educational material is produced by eFanos. After completing this unit, you should be able to understand the concept of certain, uncertain, and impossible outcomes. Understand the concept of event, sample space, and probability of simple events. Unit 6, Introduction to Probability. Topic 1, the concept of probability. The objectives are to know the difference between experimental probability and classical probability and work with both. To be able to describe probabilities as fractions, decimals, percentages, and words. We'll start by looking at experiments, which are the process of observation. For example, rolling a dice and observing which number comes up. The sample space, or the possibility set, is the set of all possible outcomes from an experiment. In the case of the dice, it would be 1, 2, 3, 4, 5, or 6. An event, usually written with a capital E, is a subset of the sample space. It's something that could occur in the experiment. For example, for the dice, we might say it's getting a 3. For another example, we might try and pick a ball from this bag. The sample space here would be the possible colours of the balls, so red, blue, and white. And the event could be getting a blue. For another example, we might try and choose a random vowel. The sample space here would be all the possible vowels, so A, E, I, O, and U, and we can use the curly brackets to show that it's a set. And the event could be getting an O. Another example might be tossing a coin. In this case, the sample space would be heads and tails, and the event could be getting a head. Try these questions. I record the colours of cars passing by my house to see how many of them are red. What is the experiment? What is the sample space? What is the event? You might want to pause the video now to work out the answers. Here are the answers. The experiment is watching the cars. The sample space is all the possible colours, red, blue, green, etc. The event is the car being red. We can find experimental probability as a fraction. We do the number of times the event occurs over the total number of trials. For example, if I rolled a dice 10 times, I might want to find the experimental probability of rolling a 6. To do this, I would need to see what number comes up each time. Maybe it's 3, 6, 4, 4, 3, 2, 1, 6, 5, 1. I then look at the number of times the event occurs. In this case, I rolled a 6 on 2 occasions. And the total number of trials here is 10. So the experimental probability would be 2 over 10, or 1/5. I can also work out a probability without thinking about experiments at all, and we call this a classical probability. To do this, we write the number of favourable outcomes over the total number of possible outcomes. So if I was rolling my dice and trying to get a 6, the number of favourable outcomes would be 1, because there's only one way to get a 6. And the total number of possible outcomes would be 6, because there are 6 different numbers that I could get. You can also write this probability with a capital P and then the event in brackets. So the probability of A is P brackets A. And we can also write this fraction as NE over NO, which stands for the number of possible events over the number of possible outcomes. Try these questions. I make toast every day for 15 days. On 4 of the days, I burn it. What is the probability that I burn toast when I make it? A jar contains 4 red, 6 blue, 5 yellow, and 2 green marbles. A marble is drawn at random from the jar. Find the probability that it is red. A letter is chosen at random from the word miscellaneous. What is the probability that the letter chosen is a vowel? You might want to pause the video and work out the answers. Here are the answers. 1 is 4 over 15. I've done an experimental probability. I burnt it on 4 days over a total of 15. Number 2 is 4 over 17. I've done a classical probability. There are 4 ways of picking a red over a total of 17 different marbles. Number 3 is 6 over 13. There are 6 possible vowels I could pick over a total of 13 letters. Classical probability can be written on a number line. If there's no chance of an event happening, then on the numerator of the fraction, it will be 0. So the probability in this case is 0. We can mark this on the left-hand side of the number line. 0 is impossible. The probability is 0%. The probability of A is 0. The maximum probability would be when the number of favourable outcomes is equal to the total possible outcomes, and our fraction would be something like 4 over 4, or 5 over 5, or 6 over 6. In other words, it would be 1. We can put this on the right-hand side of the number line. A probability of 1 is certain. It's 100%. It's 4 over 4, or 5 over 5. The probability of A is 1. And then we can fill in the gaps. In the middle, the probability is 0.5, an even chance, 50%, or a half. An unlikely probability would be something like 0.25, or 25%, or a quarter. And a likely probability would be something like 0.75, or 75%, or 3/4. We can combine probabilities by looking at all the possible options. For example, if we were rolling a dice, the possible options are 1, 2, 3, 4, 5, and 6, and these probabilities are all 1/6. If we add up all of those probabilities, we'll get 1. And this is always the case. The total probabilities of all the different outcomes always add up to 1. We can also look at a particular event, such as rolling a 1, and then look at the probability of not rolling a 1. Again, we can see that these add up to 1. So we could write that the probability of not rolling a 1 equals 1 minus the probability of rolling a 1. Try these questions. It is quite unlikely that I am late for work. Which of these could be the probability? 0.21, 4/5, 62%, 1.25. The probability that it rains is 0.1. What is the probability that it does not rain? There are red, white and green balls in a bag. The probability of red is 0.2. Probability of green is 0.5. What is the probability of white? Pause the video whilst you work out the answers. Here are the answers. Number 1 is 0.21. 4/5 and 62% are both likely probabilities, and 1.25 is off the scale. Number 2 is 0.9. We can use the rule that the probability it does not rain equals 1 minus the probability it rains. Number 3 is 0.3. The total of all those probabilities must be 1. So we work out what's missing to make the probabilities add up to 1. To summarise, experiments have sample spaces and events. Experimental probability is the number of times the event occurs over the total number of trials. Classical probability is the number of favourable outcomes over the total number of possible outcomes. Probabilities add up to 1. The probability of not A is 1 minus the probability of A. And here are some questions to finish off with. If 2 fair dice are tossed, state the probability that the sum is 7. In question 1, state the probability that the sum is 13. In question 1, state the probability that the sum is less than 13. Pause the video whilst you work out the answers. Here are the answers. For number 1, we need to work out the sample space, which is all the possible outcomes. There are 6 numbers on each dice, and 2 dice are tossed, so the total number of outcomes is 6 squared, which is 36. We then need to work out the probability of the event. The event is getting a 7. We could do this by rolling a 1 and a 6, a 2 and a 5, a 3 and a 4, a 4 and a 3, a 5 and a 2, or a 6 and a 1. So there are 6 ways of doing it. So the probability is going to be 6 over 36, the number of ways of getting a 7 over the total number of outcomes, and this simplifies to 1/6. For number 2, it is impossible to get a sum of 13. The largest possible sum would be 6 plus 6, which is 12. So there's a 0 on top of our fraction, and the probability is 0. Therefore, the probability that the sum is less than 13 is certain. All the possible sums are always less than 13. So the probability in this case is 1. This is the end of topic 1. Welcome to Grade 8 Mathematics, Unit 7, Cyber Class. This is the unit on geometry and measures. This educational material is produced by E. Fanos. After completing this unit, you should be able to understand basic concepts about right-angled triangles, apply some important theorems on right-angled triangles, understand the concept of trigonometric ratios, know and label types of pyramids. Unit 7, Geometry and Measurements. Topic 1, Right-angled triangles. The objectives for this topic are to know Euclid's theorem and its converse, and to know Pythagoras' theorem and its converse. We'll start with Euclid's theorem. Euclid's theorem says that if a right-angled triangle has an altitude drawn to the hypotenuse, like this, then the square of the length of each leg of the triangle, that's this length here, so AC times AC, is equal to the product of the hypotenuse, so that's AB, and the length of the adjacent segment of the hypotenuse, that's this segment here, so AD. In other words, AC squared equals AB times AD. We can prove Euclid's theorem using similar triangles. If we call this angle X, then when we look at the smaller triangle, this angle in the corner must be 90 minus X. If we then look at the whole triangle, the angle in the corner here must be X. So the two triangles are similar by the angle-angle-angle theorem. This means we can write a similarity statement. AD over AC equals AC over AB. And if we rearrange this, then AC squared equals AB times AD. For example, find the length AD in this triangle. We start with the formula AC squared equals AB times AD. We put in the numbers. 6 squared equals 10 times AD. So 36 equals 10 times AD. So AD equals 3.6. The converse of Euclid's theorem says that if a triangle has an altitude drawn to the hypotenuse and the square of the length of each leg of the triangle is equal to the product of the hypotenuse and the length of the adjacent segment of the hypotenuse, then the triangle is right-angled. In other words, if AC squared equals AB times AD, then the triangle is right-angled. For example, is this triangle right-angled? We need to check if AC squared equals AB times AD. So check if 6 squared equals 18 times 10. So check if 36 equals 36. Yes, it does. So yes, the triangle is right-angled. Try these questions. Check if this triangle is right-angled. Find the sides marked Y and Z in this diagram. Pause the video whilst you work out the answers. Here are the answers. For number 1, we need to check if 9 squared equals 3 times 27. So if 81 equals 81, yes, it does. So yes, the triangle is right-angled. For number 2, we start by using Euclid's theorem on this length BC. So 10 equals 8 times 8 plus y. So 100 equals 64 plus 8y. So 8y equals 36 and y equals 4.5. We now use Euclid's theorem on this side. So z squared equals 4.5 times 12.5, which is 56.25. So z equals 7.5 centimetres. We'll now look at Pythagoras' theorem, which says that a squared plus b squared equals c squared. In words, in a right-angled triangle, the sum of the squares of the two shorter sides is equal to the square of the hypotenuse. A squared plus b squared equals c squared. We can prove Pythagoras' theorem using Euclid's theorem. We draw in the altitude and we split the hypotenuse into x and y. We then use Euclid's theorem on this side, ac squared equals ap times ab, and on this side, bc squared equals bp times ab. If we put in the letters, then b squared equals y times c, and a squared equals x times c. If we add these together, then a squared plus b squared equals yc plus xc. So a squared plus b squared equals y plus x times c. So a squared plus b squared equals c squared. We can also prove it using similar triangles. First of all, divide the triangle in half, and we can see that these two triangles are similar by rotating the second one. For the larger triangle, if we flip it, we can see that this is also similar to the two smaller triangles. We can then write out similarity statements. X over A equals A over C, and so A squared equals CX, and Y over B equals B over C, so B squared equals CY. If we add these together, then A squared plus B squared equals CX plus CY, or A squared plus B squared equals C times X plus Y. So A squared plus B squared equals C squared. Here's an example. Find the missing side in this triangle. We use the formula A squared plus B squared equals C squared. So something squared plus 9 squared equals 15 squared. So something squared plus 81 equals 225. So something squared is 144, and the missing side is 12. And just check that this looks sensible in the diagram. The converse of Pythagoras' theorem says that if the sum of the squares of the two shorter sides is equal to the square of the hypotenuse, then the triangle is right-angled. So in other words, if a squared plus b squared equals c squared, then the triangle is right-angled. In this example, we can check if a squared plus b squared equals c squared by checking if 7 squared plus 5 squared equals 9 squared. 74 equals 81. No, that's not true, so this triangle is not right-angled. Try these questions. Find the side marked X in this right-angled triangle. Find the diameter of this semicircle. The foot of a ladder is placed 6 meters from a wall. If the top of the ladder rests 8 meters up on the wall, how long is the ladder? Pause the video whilst you work out the answers. Here are the answers. number 1, we do 12 squared plus 5 squared equals x squared. So 144 plus 25 equals x squared. So 169 equals x squared, and x equals 13. For number 2, we know that this is a right-angled triangle because the angle in a semicircle is always 90 degrees. So 12 squared plus 7 squared equals AC squared. So 189 equals AC squared, and AC equals 13.7 centimetres. Number 3, we need a picture. The foot of the ladder is placed 6 metres from the wall, and the top of the ladder rests 8 metres up the wall, and we need to find this length here. To do this, we do 6 squared plus 8 squared equals x squared. So x squared equals 100. So x equals 10 metres. And just check that this length looks reasonable in the diagram. To summarise, Euclid's theorem says that AC squared equals AB times AD. Pythagoras' theorem says that A squared plus B squared equals C squared. Both can be proved using similar triangles. Try these questions. The diagonal of a rectangle is 12 centimetres and the width is 8 centimetres. What is the length? If DB equals 10 centimetres and AD equals 6 centimetres, find the lengths of AB, BC, AC and DC. Pause the video whilst you work out the answers. Here are the answers. Number 1, we do x squared plus 8 squared equals 12 squared. So x equals 8.94 centimetres. For number 2, DB is 10 centimetres and AD is 6 centimetres. So first of all, we can use Pythagoras' theorem on this larger triangle to do 10 squared plus 6 squared equals AB squared. So AB equals 11.7. Next, we can use Euclid's theorem. 10 squared equals BC times 11.7. So BC is 8.57. We can also use Euclid's theorem on this side to get that AC is 3.09. And finally, we can use Pythagoras' theorem on this smaller triangle, or this one, to do 3.09 squared plus DC squared equals 6 squared. So DC equals 5.14 centimetres. This is the end of topic 1.